Hello, this is Jen from Old Tinkerer Studio. Welcome to the 6th tutorial of the Blender Basics tutorial series. In this tutorial, we will be looking at cameras and rendering in Blender. Let's start by looking at the basic camera that is part of the default scene. If we select the camera, and now we go into the Data tab, which looks like a little movie camera, we can access the properties associated with this camera. Let's look at the display options first. The display options show the limits of the camera. We can turn on or off, showing how far the mist comes from the camera. If we put a check mark next to mist, we can now see a line being drawn through the cube. We can turn on the title safe areas by checking the box next to safe areas. And when we go into camera mode, which is 0 on the numpad, we can now see the safe areas within the dotted bordered lines. We can turn on and off the name of the camera. If we turn the option on, we see the name of the camera in the lower left-hand corner of the camera view. The size parameter grows or shrinks the size of the camera icon. If we go back out of camera view, 0 on the numpad, and change the size to 1, notice that the camera has now become larger, and if we change it back to 0.5, the camera shrinks back down. The Passepartout option sets the amount of gray on the outside of the camera when we are in the camera view. If we go back into the camera view, which is 0 on the numpad, and we change the alpha to 1, we can now see outside the camera view that it's black. And if we change it back to 0.5, we get the default dark gray color in the background. Now let's look at the lens options. In the default Blender render, we have two lens options: the perspective, which is the default, and orthographic. Let's quickly look at the orthographic lens first. This type lens flattens the perspective and makes the render flat. The orthographic scale controls the apparent size of objects in the camera. If we change the orthographic scale to 10, the cube looks smaller and further away from the camera. But if we change it to 5, the cube looks larger and closer to the camera. Let's look at the perspective lens, which is the lens we will use most of the time. This lens acts like a real-world lens. The focal length parameter controls the amount of zoom or amount of the scene which is visible. Longer focal lengths result in a smaller field of view, and shorter focal lengths result in a larger field of view. By default, the focal length is set to 35 millimeters, which is the same as a 35 millimeter lens. This is basically a wide-angle lens. If we change the focal length to 135, we notice how the camera zooms in and we get a smaller field of view. If we change the focal length back to 35, we zoom out and now we have a larger field of view. Shift allows us to shift the camera up or down. If we change the X value to 0.2 and the Y value to 0.2, notice how the cube shifts to the lower left corner of the camera view. Clipping is the interval in which objects are directly visible. This is a useful option when doing special effects within Blender. If we start at 10, for example, we notice a gray bar raise it across the bottom of the camera view, and part of the cube is starting to disappear. If we do a quick render, you can see that the camera will only render beginning at the start point. Let's go back to the 3D view and change the start clipping option to 0.1. Let's go into top view, which is 7 on the numpad, and using the shortcut Shift A mesh, add a cylinder to bring in a cylinder. Then move the cylinder so it is off to the left of the cube. Then using the shortcut Shift A, go to Mesh and then Cone, and move it to the right of the cube. Select the cube and add a material to it. Go to your Materials tab and change the diffuse color to red. Then select the cylinder and give it a material also. And we'll change the diffuse color to blue. And then select the cone and give it a material, and we will give it a green color. Go into front view, which is 1 on the numpad, and using the shortcut Shift A, add a plane. Now move the plane below the cube and size it using the S key and the number 6 and enter. Then let's give the plane a diffuse color of purple. Let's then select the lamp and change it to a hemi-lamp. And if we render the scene, we notice that all the objects are in focus. And this is because we don't have a depth of field. Let's make sure that the camera is selected and go back into the Data tab. If we go to the display options and turn on limits, you will notice that we have a cross at the camera. This is the depth of field distance. If we change the distance to 3, notice that the cross moves closer to the cube. This is telling the camera where it is going to focus. In order to actually use the depth of field, we need to work with nodes. Let's split the 3D viewport into 2 horizontal areas and change the top area to a node editor and change the bottom area into a UV image editor. We need to use composite nodes, so click on the compositing node icon, which looks like pictures, and then click on Use Nodes. We now have 2 nodes, Render Layer and Composite. We can now add any filter to this node setup to make changes to the scene. Since we want to add depth of field, let's add a defocus filter by going to Add, Filter, Defocus. Once we place this node in between the other 2, notice how the image inputs and outputs are automatically connected. Now we need to connect the Z buffer output from the Render Layers node to the Z buffer input of the Defocus node. The f-stop is related to the depth of field. An f-stop of 128 means an infinite depth of field. What this means is that the higher the number, the less depth of field, and the smaller the number, the more depth of field. Let's change the f-stop to 2. And if we render the scene, we can see a distinct defocus effect. The maximum blur changes the blur of the scene, and we'll just leave that at the default. Threshold determines how wide the focal area is. The larger the number, the more stuff is in focus. If we change the threshold to 10, for example, and we render the scene, we will notice that the cube and the cone are in focus, but the cylinder and part of the plane are still out of focus compared to everything being out of focus when we had the threshold set at 0.2. Let's now look at setting up constraints of a camera. Let's start with a clean scene by going to File, New, Reload Startup File. If we select the camera, we notice that we can move it like any other object. However, there are times when we want the camera to be pointing at a specific object and be able to move the camera while keeping the object centered. This is where constraints come into play in Blender. Select the camera and go into the Constraints tab, which looks like a link. The easiest way to focus the camera on a specific object is to use the damped track. Click on Add Object Constraint and then Damped Track under the Tracking option. We can select a target by clicking in the target field and then select Cube. We can now see that the camera is pointing in the wrong direction. This can be easily fixed by selecting an axis. In this case, the -Z axis will point the camera in the right direction. Now if you move the camera, we can see that it is always pointed toward the cube. Oftentimes we don't want to point to a specific object, but rather to a target in the scene. We can do this by using a helper object, and in this case we will be using an empty object. Use the shortcut Shift-A, Empty, and then Plane Axis to add an empty to the scene. Use the manipulator and move the empty above the cube. This is a simple crosshair target that will not render in the scene. Select the camera and go back into the Constraints tab. Then under the Tracking Objects, we're going to be choosing Empty as our target. Now notice that the camera is focusing on the empty instead of the cube. This is very useful when doing animation in Blender. Let's now look at the render properties. Click on the Render tab, which is the camera icon. In any scene that we may have, there is always the Render Properties option. The first option that we see is the Render Properties. We can render the scene, we can render animation, and we can also render audio. We can also choose how we want to display the render. We have the option of displaying the render in full screen, image editor, new window, or keeping the UI as it is. We have a number of render presets also available to us. When we select a preset, it changes the resolution settings, aspect ratio settings, and the frame rate. If we choose TV NTSC 4:3, notice that the resolution changes to 720 by 486. The aspect ratio is now 10:11, and the frame rate is 29.97. Anti-aliasing smooths out the edges as it renders the scene. The higher the number, the longer it will take to render the scene. Shading is an option that we've already seen, and it deals with the shadows and ray tracing. Performance tells us how much of the computer will be used to render the scene. Auto detect will detect how many processors you have in your system, and you can adjust the number of threads to limit the resources used for rendering. The output option is where we can choose how and where to save our files. By default, Blender saves the files to a temp directory, but we can change this to any folder or drive we wish to by clicking on the folder icon. We can export as PNG, JPEG, TIFF, or bitmap, as well as many other formats supported by Blender. We also have movie formats for rendering animations. This concludes the Blender cameras and rendering tutorial. Next week we will learn about basic animations in Blender.